Alright, IBSL1. I decided we needed one last video to tackle some of the harder problems from the binomial theorem. We've kind of been doing some of them a little bit here and there, but I just thought one more video to bring it all together. First of all, the binomial theorem is basically that every term in a binomial expansion is of this form right here. Please notice that for today I'm using n choose r instead of little n capital C little r. I think this makes more sense to me, but it's the same thing. So the first problem we're going to do: find the term independent of x, or the constant term. So if you see the term independent, this is the same thing as the constant term. It just means whatever term in this expansion, if you were to expand it all out, whatever term would be free of x's. It would just be a number on its own, an integer. First up, what this problem would look like in terms of each term in the binomial would be 5 choose r, because it's being raised to the power of 5. The front term here is 4x cubed, so I put the front term here. The back term is negative 2x squared. I mean negative 2 over x squared. Now there's a small thing that I did in between here, that this here, instead of having x squared in the denominator, I moved it back upstairs to become a negative. So this is the same thing as negative 2 times x to the negative 2. So anytime you see variables in the denominator, in order for the binomial theorem to work, you should move them back up to the numerator and make their exponents negative. So this is here. So every term is of this form right here. Now, the next thing we're going to do is something I call the power game, because we're looking for when for the term independent of x, or the constant term, which means we're looking for x to the 0, because x to the 0 is 1, and then that would just be your constant term, you know, whatever coefficient is in front of it. So if there was some number in front of this, then this part is just going to become 1, and then the whole thing will be the constant term. So since we're looking for x to the 0, this is the power you are looking for. Now, what's set equal to 0? Look here at x cubed being raised to the 5 minus r. So because there's an x involved in that, I'm curious about its power. Remember that when you have power of a power, that this 3 will get multiplied with this 5 minus r. So that's where this 3 times 5 minus r comes from. It's the power attached to x in that front term. Now, in the back, there's also another x right here with a power. Now, power of a power between negative 2 and r will just be multiplied and become negative 2r. When you multiply this term and this term together, they both have x's, bases of x's, so their powers add with each other. Thus, to bring it all together in the power game, 3 times 5 minus r is going to get added to negative 2r. Now I need to solve that power game to figure out what value of r is going to produce an x power of 0. So this is 15, take away 3r, minus 2r is equal to 0. This becomes negative 5r. Let's kick that 15 to the other side. So r is equal to 3. Now, this is just one piece of the puzzle, because now I know if I replace this, this, and this with 3, I should get the term that's independent of x. Let's try it. So, in the binomial theorem, that would be 5 choose 3, because we're replacing r with 3, because we found r from here, times the front term to the power of 5 minus 3, times the back term to the power of 3. Now, 5 choose 3, that front thing there, that front coefficient from Pascal's triangle, I'm going to do, I could do a quick triangle because it's not that deep, but 5 choose 3 on your calculator is 10. So So this becomes 10 times 4x cubed. 5 minus 3 is 2. And then here we get negative 2. I guess I'll just let that one lie for a second. Then remember that this 2 has to get applied to both the powers here on 4 and on x cubed. So this will be 10 times 4 squared times x to the 6th, because power over power you multiply. Then this will still be multiplied with negative 2 cubed. Remember that this cube has to go to this and to this. Times, x to the negative 6. So now let's just rearrange, get all the numbers in front and all the variables in the back. So that means up front I have 10 times 16, which is 4 squared, and then negative 2 cubed is negative 8. And then I have x to the 6 times x to the negative 6. You guys, what happens when you multiply x to the 6 times x to the negative 6? You add their powers, which means 6 plus negative 6 is 0, which means if I just multiply the 10 times the 16 times the negative 8, I get negative 1280 times x to the 0. But x to the 0 is just 1, which means negative 1280 is my answer. So that was finding the term independent at x, or the constant. You guys, that whole power game piece right here is a big part of figuring out like what R value is going to give you what you want from the expansion. Let's try another one. Find the coefficient of b to the 6th in the expansion of this whole mess right here to the 12th power now. So if I take the front thing here, front thing, back thing here, and kick the b from the denominator up top and make it have a negative power. This is what every term in the entire expansion will look like. It'll be of this form, but with different r values. So the power game. I see a b in the front and a b in the back, which means both of their powers are going to get added together. 2 times 12 minus r and negative 1 times r added together. Here's 2 times 12 minus r and negative 1 times r. Then a quick solve on this power game. Here we get negative 3r, 6 minus 24 is negative 18, r equals 6. Oh yeah, if you ever do the power game and you get like 2.5 or something like that, you might have made a mistake, because the r values should be whole integers. So now that I have my r value, I'm going to plug it into this, but replace all the r values with 6. So hopefully the term attached to b to the 6th is 12 choose 6, 2b squared to the 12 minus 6 times negative b to the negative 1, all to the 6. Oh, also, I want to say that in this case, we were looking for the term that contained b to the 6th, and it happened to be when r equals 6. That is total, like, a coincidence. It's not always going to work out like that. It's just this particular problem where it did work out like that. Okay, let's do some simplifying. On my calculator, I'm going to do 12 choose 6 with that math probability button. Number 3, 12 choose 6 is 924. Then this is just a 6, so when you distribute it to this and to this, you get times 2 to the 6th, and then this will be times b to the 12th. Here, the power of 6 needs to get distributed to the negative 1 out front and to the b to the negative 1, but negative 1 to the power of 6 is just positive 1, so we don't really need to worry about it. And then this just becomes b to the negative 6. Please notice that when I'm going to multiply these and add their powers together, that we will get 12 minus 6, which is positive 6, which is good news, because that's what I was looking for. 2 to the 6 is 64. There it is. Although I think they asked for the coefficient. So the coefficient is... And we're done. Alright, one more problem. Find the term containing a cubed in this expansion. First thing I did is I put it into the binomial theorem where front thing's here, back thing's here, and I still haven't solved for r. Now, the mistake I will see from students when they go to do the power game is they will do 9 minus r plus r and set it equal to 3 because they're looking for the cube power. But that mistake is we only want to find the term that's containing a cubed. Notice there is no a in the back term. There's only an a in the front term, which means when you play your power game, you only play it with the powers on a. As opposed to up here, when I went to play the power game, there was a b in the front and a b in the back. So that's why you have to add these two terms together. Now, this is a pretty quick solve to find the r value that produces a cubed. So you subtract 9 from both sides. Negative r equals negative 6, so r equals 6. That means we're going to rewrite the binomial theorem, but instead of r, we will write 6. Now we need to simplify that. 926 on my calculator is 84 times 2 cubed, because you have to distribute that power of 3, times a cubed times negative 3 to the power of 6 times b to the 6th. Now, I'm going to move all the numbers to the front. And all the letters to the back. Now I really need to use my calculator just to determine this front coefficient. So I guess we could put it all in. 84 times 2 to the cubed. And then 3 to the 6. Negative 3 to the 6, but the negatives will cancel out because it's an even power. 4, 8, 9, 8, 8, 8, a cubed b to the 6th. Now, did we need to find the whole term or just the coefficient? Yep, find the term. Okay, so this is the actual term, so this is our answer, right? As opposed to if they had said find the coefficient of the term containing a cubed, our answer would just be the number up front, but that's not what they asked. Okay, you guys, hopefully that gave you some good more insight and practice. Test coming up soon. Study up. Ask those questions.